Good morning. I kick off. I've been asked to say just two things. One is, please give your turn off your phone in airplane mode or something like that. And secondly, you'll get an email asking you to rate my talk. Please do fill that in. If I turn out to be awful, you can spare future attendees ever happy to hear from me again. If it does go well, I would appreciate it if you mention that as well. But hello, my name is Chris Knowles. I'm going to be speaking today about software architecture for games and what I've learned about that since I joined the industry in 2007. And I'm going to talk about how I've applied all of that in the currently working on circumstances and how we can do the same approach. So let me tell you quickly just a little bit about my background. I got my first job in the industry, as I say, in 2007, Jagex, with most RuneScape. But I wasn't working on games then. I was writing software for free things like a billing system and a bit of the website and how RuneScape capability, that sort of thing. But let me have a crack at making games in 2009. And while I was there, I shipped 3 games, Chronicle, I mentioned a couple of times here and there. And I spent about 7 years working on the engine for different flavors of RuneScape. At the very end of 2019, I went indie. I reduced my hours at Jagex down to 25%. And I started full production on Hexahedra last year. That's what I'm working on at the moment. That's the game I mostly be using as an example today. And in May this year, I went all in and I left Jagex completely. So, what I'm discussing today is building outside the engine. I'm going to be trying to convince you that whatever your engine is, whether it's Unity, Unreal, or something you've written yourself, for some games, there is great value in writing as much of a game as possible separately for that engine. So Hexahedra uses Unity, but Unity is only there to show the player what's going on, to gather the player's input. The core logic of the game is squirreled away in C# DLL. Now, given that we are in Brighton, and I know there's probably a big Unity contingency in the interest of not being lynched, let me say I do like using Unity as an engine. I did choose it from those available when I set out to make Hexahedra. But as with any powerful tool, it's a very easy place to tie yourself into knots. So the first thing I really want to do today is convince you that this approach is worth pursuing, that there are real benefits. Then we'll dig into how I actually achieved it. But this is all going to be a little bit easier if we've got something concrete to hang on. So let me very quickly show you how Hexahedra plays. So it's an open-ended programming puzzle game in the same genre as things like Space Camp, that sort of thing. This is a very early level. We haven't got as far as branching logic and big complicated loops yet. A very small factory. But I do have a factory that produces cubes. My aim in this level is to produce copies of this cube, which has got these 4 wooden panels around the rim, metal panel painted red on either side. And what I've got to lift that with, my inputs, I've got that wooden rim, I've all pre-built source of 2, and I've got up here source of 1. But it isn't quite right. It's 4 metal panels all stuck together in one configuration. So I need to build a factory that will kind of pull those apart, join them into the wooden panels, ship them off, and solve the layout. And each of these sort of square frameworks is an individual workstation. They're controlled separately, but you can coordinate. And I can add devices to them. So if I'm ready to ship something, I'll add a shipper here. On this person, do that. This thing is a panel out of the move, but I can sort of pull the people apart and reassemble them later. That kind of thing. And then the programming workstation, I've got the command track. And if I wanted to say trigger the source I'm going on, I trigger the top device, put it there, that becomes trigger source of 1. If I want to update the queue, I can take it, I can set it to different things, that kind of thing. I can add more tracks up on to do some really good space. Now, to fully become this puzzle game, let me show you a solution that actually runs. Let's use the old UI in the middle of rewriting the UI. The old one was really desperately trying to make it but the new one was on someone who knows what they're doing, and it's mostly If this will solve the level, you'll see two workstations kind of working. This will solve the level. And you can see as I'm pulling this cube apart into its constituent bits and storing them over here, sliding the wooden ones over, slapping another one on, it's shipped, great, done, build another one. And this then loops. You can see this one is waiting on a sync command until this one syncs in the other direction. It loops at the end. And also notice everything is proceeding in steps. So although this one waits occasionally, when they're running, it takes exactly the same amount of time for every command to run. That will turn out to be relevant later. But once I've shipped the right number of commands, we will see the old, ugly level complete screen, but we are basically there. So that's roughly how the game plays out. Why should you build outside your engine? Why is this worth doing? What are you going to get out of it? So there are a few big advantages. I'll explain 3 of them thoroughly now. We'll come back to 2 of them later. The first one is compactness. So the core DLL that powers all the logic of the game essentially says, does this factory solve this level? That's all squirreled away in a DLL called HexSim. And that takes the solution, works out whether or not it passes or fails. And that contains all of, according to Visual Studio's code analysis tools, 2,082 lines of executable code. It's very small. And in fact, that includes some code just to serialize and deserialize JSON from the Newtonsoft. By contrast, the Unity side contains, last I checked, 13,592 lines of executable code. And I'm currently working on the demo version, and some things aren't implemented yet, so both of those numbers will go up. But having the core logic of do we solve the level decoupled as much as possible from the Unity side, rather than kind of being referenced by it in various scenes or even kind of distributed through 13,000 lines, just makes it much, much easier to reason about. It's much easier to kind of work out, am I solving this level properly? Is the factory doing what I want it to? And keeping it separate from the UI and so on is very handy. And in fact, it also, as well as giving you quite small bits of code that are easy to think about, it makes it very easy to test your code. So you can write unit testing in Unity. I quite like Unity's framework for this. You have editor mode tests that are essentially normal unit tests. There are play mode tests where Unity runs the full game loop in the background. So you can add a thing to your world, tell it to do something that will take several frames, wait for the frames to run, check you're in the right state, and so on. But having said all that, code that isn't wired together, at least in part, through references in a scene or lots of get component calls at runtime or whatever, it is just much easier to test. And lots of Unity tests turn out to be integration tests, which is fine, they're good, but they're not quite the same thing. And so keeping the core logic outside the engine made writing tests for, do we solve the level correctly, much, much easier, because that has to be absolutely rock solid. A few UI bugs, minor ones, I'll live with those. Does this puzzle solve this level properly? Has to be absolutely rock solid. And so I've unit tested it up, down, and sideways. There are 482 unit tests, which consist of 3,243 lines of code. There's more test code than actual game code. And unit tests aren't foolproof. If the test is wrong, that doesn't help you at all. But I have an extremely high level of confidence that this simulation does do what it's supposed to and what I think it does. And I haven't found a bug in the Hexim side in literally several months. So I've got some really robust code. The next big advantage, if it's useful to you, is having some lightweight servers. So Hexahedra is a single-player game, but there will be a stats server that will track players in an anonymized way, so that the game can show you graphs of how your solution kind of compares with the rest of the world. So again, if you've played Space Chem or Opus Magnum or something like that, you'll be familiar with that. That's the Opus Magnum end screen. And that server doesn't exist yet, but it will need to verify the results by running the solution for itself in order to make sure that the stats that someone is claiming to have got are in fact legit. And for some games, like an online FPS, the server, for very good reasons, runs the entire game engine on the server side. It'll be in a headless mode. It won't be rendering any graphics, but it'll be maintaining a 3D scene. It'll be running the physics engine and so on. And that limits how many concurrent games you can get running on a single machine. In fact, you might find that limit is 1. But because all I need to verify a solution to a puzzle for Hexahedra is just that little DLL, the server-side verification doesn't need to run Unity at all. It'll just need to receive the solution, run it through Hexim. I can take all the breaks off when I do that. I'm not waiting for Unity to say, yes, I've shown the player this step, let's have the next one. I can run it as fast as possible. And this will hugely reduce the server capacity I need to supply the stats system. If the game logic was wired into Unity, I'd have to run Unity on the server and then work out how to make that go as fast as possible.
We did a similar thing with a Jagex, and we made Chronicle. So that's a RuneScape-themed card game. The client for that was in Unity. The server side was pure C#. And so the logic for resolving cards and maintaining the game states, that was all C# stuff. And that ran both on the server side for PvP, it ran on the client for the single-player practice mode. And the server was written using the C#'s rather lovely async await paradigm. And that meant that a game on the server would just go to sleep when nothing was happening. It wouldn't take up any CPU resources until a message from a player arrived. And that meant that the Chronicle servers could support several thousand games simultaneously on a single machine. If we'd been running Unity instances, that would have been very different, and the server costs would have been several orders of magnitude higher. So there are two other big advantages. They're much easier to describe once we've looked at the game in a bit more detail. One big advantage, again, primarily for multiplayer stuff, and we took advantage of this heavily in Chronicle, is that this approach is great for feeding data to your analytics team. You find it much easier to do that. And finally, doing it this way for Hexahedra did allow me to invent time travel, which I will come back to later. Now, it's not going to make sense to build every game this way. So I've already mentioned that, an online FPS is very sensible to run the code and engine on the server, to have everything much more closely linked. So what features of Hexahedra make it a good choice for this approach? The main one is not having any important physics. So there's no physics calculations required to answer the question, does this factory solve this level? Unity does use physics for things like particle effects. There's a drop painter that drops a big blob of paint down until it hits something, and it splashes everywhere and paints the insides of cubes. That's all modeled with gravity and so on. I don't need the physics to work out, do we solve the level? And if I did, I'd have to I'd need to run Unity on the server. I'd have to be tied much more closely together, or I'd need some sort of third-party physics solution, but then I'd have to integrate that into Unity. That'd be awkward. So it is very useful not needing the physics for anything game affecting. The next one, not a deal breaker, but not having any real-time input. So what I mean by that is that once the factory is running and Hexim is working out, are we solving this level, you can't edit the factory at that point. If you want to change it, you stop the run, change the factory, start it again. There's nothing stopping Hexim receiving updates on the fly. In fact, in the early days, it did do that, and I was helping debug a few things, actually, sticking extra devices in at random times. But it's fixed in place. Obviously, when you are editing the factory, we do send messages from Unity to Hexim saying, hey, we want to put this thing here. Hexim is in charge of whether that's allowed or not. It will reply with a yes or a no. Obviously, the Unity side shouldn't be telling it to do something that's invalid, but by having Hexim be the authority, we avoid it getting into a bad state. But when you load up a solution off disk that you've worked on before, or if you're the stats server and you're receiving a solution to verify, that arrives just as some JSON. And we set up the state of Hexim just from that rather than from player input. And if there was sort of real-time input during a run and we needed to verify that, I'd need to get that into some format that I could send as JSON. So I'd need to be able to encapsulate all that real-time input data in some sort of structure. I'd have to tag things in relative timestamps. It's all doable. It's just a lot more complicated and a bit more faff. So not having to do that, again, makes this a bit easier. Finally, it's relatively easy to get all the information I need out of Hexim. So at some point, I do need to tell the player what's actually going on in their factory. We need to play the right animations. We need to move the cubes around the factory. We need to edit them in the right way, take panels off, spray paint them, that kind of thing. I need some way to extract the information from Hexim and give it to the Unity side. And obviously, what I don't want to do is just make every single thing in Hexim public and have Unity just poke it wherever it feels like. So we'll look at that more in a moment, but because the factory proceeds in steps, I can send a list of events, not in the C# sense, just bits of data, about what happened in the factory on a given step. And these contain enough information for Unity to then play out the next couple of seconds of factory animation. And because I'm making this deterministic puzzle game, the number of different events is quite limited. There are 37 concrete event types. But if things got too unwieldy, if there were vast numbers of them, or if I needed to supply them at very high speed, if I was trying to do some sort of complicated end run around the physics system and I had to supply updates 50 times a second or something, that might get a bit unwieldy. But if you meet these requirements, you can get real benefits out of doing things this way. So how is it actually set up? How have I built this thing? We'll look at the Hexim side first. It probably won't come as a huge surprise that the code structure mirrors pretty closely the kind of the visual structure you saw before. So we start out with a puzzle. Don't worry about reading every line of UML. This is just to give you a feel for the shape. But it knows about what we're trying to make. It's got the targets. It knows what we've got to work with. It's got the sources. There are other constraints like which devices are actually enabled in this level, how big is the factory, that kind of thing. So we have a factory, that's what the player uses to solve the level. The factory has one or more workstations. The workstations can contain up to 5 devices in different positions. They've got one common base class. And they also have up to 5 command tracks, and the commands go in the tracks. We also have the cubes themselves. I did actually call the class Hexahedron because I just like it when namespaces mean you don't have to, but I like it when all the classes have distinct names. And Unity has a thing called cube already, so I didn't want to do that. But this isn't in the Unity side. This is all just C#. There are no mono behaviors or anything there. But we have this nice hierarchical structure for how that thing is set up. So if the puzzle wants to know what happens in the next step, it asks the factory. The factory says to each workstation, sort yourselves out, work out what you're doing on this step. The workstation looks at its next command it needs to execute and works out what to do. And that might be something like trigger the device on the left, take your cube and send it to the workstation below, something like that. But if we were, say, triggering a spray painter, you know, it would need to ask the device to do something. It will then paint the relevant side of the cube, and the workstation can then work out what the next command it should execute is. And because some devices like the laser allow branching, the workstation will need to check kind of what the device has done. So the laser fires a colored beam out, and if it hits something that's the same color as the beam, it'll get a return signal, and you can configure it so that whether or not you receive a return affects whether or not you branch the logic. You can either carry on or you can go up or down. One sort of nicety of this system is you may notice there are, if you can read that, we actually do the step in 2 passes. This is because some devices like the laser trigger very late. So if you're firing a laser and it's going to hit a cube that's in the middle of being painted a different color, or it's in the middle of rotating, it's very hard for the player to reason about quite what the laser is going to see when it fires. So to avoid that, we just wait for everything else to finish. The spray painting finishes, the rotation finishes, then we fire the laser. So that makes it easier for the player. The actual internal reason is that although all the workstations kind of visually play out what they're doing at the same time, they're evaluated in turn. So if you had a laser firing at a cube in a different workstation that was rotating, which face of the cube the laser would see would depend on which way around they were physically, which isn't very nice. It's not very easy to reason about. It's not easy to present to the player. So we do them in a second pass. But because everything is squirreled away from Unity, that's relatively straightforward, and it's still pretty neat. And this gives us everything we need to see if the factory does in fact solve the level. So we update the internal state within Hexim as we go. We're generating those events to display on the outside. And unless the player has set up some sort of degenerate solution that never resolves, eventually we are going to get either a puzzle complete event, which is really what you want. The puzzle adds that itself when it sees that you've shipped the correct cubes, or some variety of failure event if they do the wrong thing. So if you ship the wrong cube, or if you smash 2 cubes together in your factory, or if you say, send this cube to the workstation on the left, and there isn't one, and you just left the factory, that's a failure. But we can check solutions, we can check if they work. This is enough to build the stats server with. We've got output we can give to Unity, and so on. And again, as I said, I don't want to do this. So what we've got instead is a clean separation. There's one point where the information kind of changes sides, and that's where we create all those events as we go. So on the Unity side, we have a very similar looking hierarchy that allows us to show the player what is going on. So we have a U puzzle. And again, for the sake of my sanity, I've made all the class names unique. But that sets up a Hexim puzzle object. That sets up everything it needs. And we have a U factory and a U workstation and all the other bits and so on. And so when the U puzzle sees that it's finished playing out the current step to the player and it needs a new one, it asks the puzzle for the next step's events. The puzzle goes down its hierarchy, gathers everything up, sends them over, and it can then send those events down to the different bits on the Unity side. So most of the events are tagged with the workstation they happened in, so the U workstations can pull out the events that they care about, and so on. So if we triggered a red spray painter in Hexim, that would produce a trigger device event, which really is just there to say to Unity, hey, you need to animate this thing, move it into position, make some VFX happen. And if there's actually something to paint, we'll also get a set face front color event, which will say, make the bottom panel red or whatever it is. And these get passed up the chain, up to there, they go across over to here, and they then get passed down to the relevant bits. So the spray painter would handle the trigger device event. And if there is anything to do, the U hexahedron would handle the set face front color event. So those events are separate because if there was no cube there, we still want the trigger device event, we still want the animation to play, but it wouldn't actually do anything. So we've got these 2 parallel structures, and we pass messages up and down, but effectively, a workstation can talk to a U workstation, sort of in a roundabout way. And this always reminds me of the OSI networking stack model, if you're familiar with that. So this is talking about how 2 programs send messages to each other. And you can think at a higher layer, level 7, where you say, my game is sending a message to my server. But if you were to come down to level 4, you'd be thinking in terms of what we're doing is setting up a TCP connection to the server, and we're kind of passing data that way. Layer 1 is I'm sending some bits to the other end of this thing, and something's going to take care of that at the other end, I guess. You'll even see people talking about layer 0, which is I've got a wire and the voltage goes up and down. And in the same way, we have a structure where the factory can talk to the U factory, a spray painter can talk to a U spray painter, but it's not actually done directly. We pass messages up one side and down the other side. And so the only place messages actually cross over is at the top there, and I guess that is like the wire with the voltage fluctuating. So we've got the two halves separate, and the Hexim side is clean in a way that the Unity side just isn't. Something that will very quickly throw a spanner in the works when you're trying to keep stuff encapsulated and decoupled is UI work. If you've never done any UI programming, you may not realize just how many different things will affect one tiny bit of the gate of the UI state. Should you show the busy mouse cursor? Any number of things could trigger that. You don't really want the mouse cursor to know about all of them. You don't want all of them to know about the mouse cursor. You don't want some horrible spider web of references. The standard solution is to add some sort of messaging system where there's a central clearinghouse for these things. The mouse cursor can sort of register interest in certain kinds of events. Things that might affect it can send events to that one place, and they then get distributed. I've got that in the Unity side. There's a thing called the event exchanger that does that. So as an example, you may be sitting there thinking, you're talking about spray painting a lot. I hope this game has some sort of colorblind mode support, which it does, which on this projector might be hard to see. I've yet to do any acceptance testing for how this works. If you have any form of colorblindness and you'd like to have a look at the beta and give me some feedback, I would love to put a key in your hand. I'm not the person to decide if this works. But if I turn it on, there'll be a brief pause where we do some async loading, and then this will change in a way you may not be able to see in this lighting condition, but there are now some triangles all over it. So each color has a different shape associated with it to help you distinguish them. And what happens when I click that is that sends a message to the event exchanger. Everything that's registered to receive, we need to change into colorblind mode or out of it. Goes and does some async loading. They get handed a token they can pass back later. When the tokens all come back, anything that's registered for, I need to do something when we've loaded all that stuff up, then goes. So all the cubes will then go and load up, the new textures and change their appearance. There we are. But it may be actually kind of what you're really thinking is, well, this is all very well, Chris, but what about the analytics and the time travel? So let's have a look at those. And these both stem from this architecture being powered by an event stream coming from the core logic into the Unity side. So we'll do the analytics first. And again, we did this a lot in Chronicle. So the way this worked, you laid out up to 4 cards you could play in your turn. Your opponent did the same. And the server would then work out the consequences. Your adventurer would encounter your cards. Their adventurer would encounter their cards. They would then influence each other. So you kind of mess up each other's plans. That's kind of how the game worked. And it would process all of that, send a whole load of data back to the client for it to play out to the user. And we did a similar thing kind of in the permanent profile side as you were unlocking things as you leveled up. That was all a set of events that were then applied as transactions to a database. And when we wanted to run analytics on the game, both in terms of how players are acting inside a match, is one card being played all the time because it's just overpowered? We had all the data we needed ready to go. We could just send all of that data about what happens in the turn straight to the data warehouse for the analytics team at Jagex to look at. And again, in the permanent profile stuff, are players using the stuff they're unlocking? Are they building custom decks? We had a load of events ready to go that we could just send straight to them. We had to do some reformatting because apparently they really like CSVs, but other than that, it was all ready to go. We did generate a few extra events just for them. So as you were playing, if you were putting a card down, picking it up, putting it down somewhere else, that would all generate events so we could kind of see how players are interacting with the game. But by and large, all the core stuff was all ready to go, and we got it basically for free. And I think, by the way, this is an argument for hiring, or at least talking to developers who don't just make games. The seeds of this really came from my work on the Jagex billing system in 2008. With financial stuff, you generally do work with a series of transactions, either in the both in the database sense and in the financial sense. I basically designed the profile server for Chronicle like a billing system, and it gave us this really fine-grained detail on what players are doing in the game, kind of more or less for free. And I really don't think I'd have done that if I didn't have that prior experience. So talk to non-game devs; they'll tell you cool things. Now, Hexahedra, it's a single-player game. There aren't things like game balance concerns like you have in PvP, that kind of thing. And my natural inclination is to minimize data collection and kind of maximize player privacy. So I'm not going to be going around collecting lots of data on the minutiae of how players are tackling hexahedra levels, but the core approach is the same. The data would be there if I needed it. All right, so that's the analytics. What about the time travel? When you're playing games of this type, you're playing Opus Magnum or Space Game or something like that, and something goes wrong and you fail the level, generally speaking, the only way to go back and work out what happened is to go right back to the start and watch it all the way through, which can take a while. And if you then miss the bit where it all went a bit wrong, you have to stop it again and go back to the start. It all gets a bit tedious. And it occurred to me it'd be really handy if I could rewind the factory just a bit and then watch it do that bit again and then kind of go back and kind of see what was happening. You know, if the game tells me, hey, you've smacked 2 cubes together, I want to be able to back up and work out where exactly I did the wrong thing and where I sent something in the wrong direction. So we can see this in action. Let me go and grab a different level. We're going full Blue Peter. Here's one I made earlier. Where was it? It's that one, isn't it? So this is a level that's already set up and works. I'm going to mangle it slightly, and then we'll see, oh, look, it's broken. How do we fix that? So here we are. So this will do the right thing. So my output here is 1 complete cube, but my input is 2 panels stuck together. So to make a complete cube, I've got to put 2 panels in, rotate them out of the way, put 2 more in, rotate them again, slide the other ones in to make a complete cube. And I've got to get those rotations right. So if I just mess this up, you know, we come along, we say, right, okay, I put 2 panels in, I rotate them a bit, okay, they're out of the way. Next lot comes in, brilliant, finally, do some spray painting, and oh dear, it's all gone wrong. There's a panel on the front of this, there's a panel on the front of that, they can't slide together, they've collided. That's Dantar, he's telling me, he's the tutorial dude, he's telling me, you know, it's all gone a bit wrong. You know, I can sort of see it play out again if I want to. And what I want to be able to do is, it'd be nice if I could just go back a few steps and I could say, well, hang on a minute, how did we get in this situation? Because, you know, this bit worked, that was all right, okay, that's fine. And we rotated it a bit. Hang on, where are we? So, got my cube here. Where? Okay, here we go. The empty spaces are there. What I need to do is rotate it that way, and what I've actually done is rotate it clockwise. That's no good. What I need to do is this. This should make it work. And we can then go along and say, yep, there we go. That's a complete cube. Boom, we've shipped it. And we're now proceeding. So there you are. So it's a very nifty tool for debugging your solution and working out exactly what went wrong. Now, as far as I know, no other game in this genre has a rewind feature. I may be wrong, but I've not come across any. But because I was supplying all the data to Unity as a series of events, getting it working in Hexahedra's case was, dare I say it, pretty trivial. Took about 3 days to get it working at a basic level. There are a few weird animation problems when I sort of resumed, and devices flailed wildly, but we got to the right point. But if the simulation had been closely tied to Unity, getting it to run backwards would have been a nightmare. And it may well be, I'm guessing, I don't know, but it may be that that's kind of why no one else has put a rewind feature into a game kind of in this genre. You know, so this isn't a feature I planned from the start. It's not a reason I made the game this way, but oh my goodness, am I glad I did, because this is actually quite a big, unique selling point for a game in this space. So how does that bit work? Well, as I said, it wasn't actually all that complicated. There isn't much more to add. I get this list of events from Hexim, and rather than just passing them to the factory and the workstations and then forgetting about them, I just keep track of them. So I store all the events for the 500 most recent steps. So I do eventually throw the old ones away so we don't have an unbounded memory usage. And when I want to be able to rewind, I need to be able to recreate the state of the factory at any point. And it turns out really the thing I need to worry about mostly is what state of the cube's in. The factory itself doesn't really change. There's a few niceties to do with the lasers triggering late and moving at a different time to everything else. But basically I need to keep the cube state tracked. And either I need to go right back to the start, play everything forward again to the rewind point and work out what state the cubes are in. But that'd be pretty heavyweight. That would take a while. I'd create loads of game objects and destroy them before I'd even rendered them. And also I couldn't throw the old events away. I'd have to keep all of them. So instead, I just record the state of the cubes at the end of each of the last 500 steps as well. And at the end of a step, a workstation can only have a maximum of 2 cubes associated with it. There might be one in the middle that it's in control of. If it's sent one to another workstation, that transition takes 2 steps to play out. So after one step, it'll be at the halfway point. So there's a maximum of 2 cubes per workstation on the boundary of a step. So that's not too much data. And so when I rewind, I rebuild the cube state at the right point. And then when I hit resume, I just start playing events out of my stored list. So Hexim, the DLL bit, has no idea about the rewind feature. It's completely oblivious. I just, rather than asking it for data, I just use the data I've already got. There's a few other wrinkles to worry about. I have to deal with cubes unshipping if you rewind far enough, that kind of thing. But essentially, That's all there is to it. There's one big refinement I'd love to make to this system would be a smooth rewind. It'd be great if as you move the slider, kind of cubes kind of nicely move back and forth. Obviously, that's a bit more complicated. There's all kinds of niceties to do with that. You can't run a particle system backwards in Unity, for example. But I am aiming to add that, for full commercial release. But there we are. This, by happy circumstance, allowed me to add a rewind feature, some time travel to my game. So if your game is suitable, I really would strongly recommend building as much as possible outside the engine. So your core code will be compact, it'll be easy to reason about, it'll be easy to test. If you need some kind of server, it'll be easy to run a lightweight server. If you want analytics, you'll find the data is kind of all there, ready to go. And you might find you can also add some extra cool features you never thought of, like rewinding time. That brings me more or less to the end of what I wanted to say. There are just two things left to mention. One is that we have some time in a minute for some questions. The second is that although the demo isn't out yet, Hexahedra has a store page. If you're into programming enough to come and listen to a talk about it, I think there is an excellent chance you'd enjoy playing Hexahedra. So do go and wishlist it. If you want access to the beta before the demo's out, come and find me. I can put a Steam key in your hand. But thank you very much for listening. Do we have any questions? There is a microphone that will go around, I think. Yeah. Sorry, can you wait for the mic so the people on the stream can hear it?
Hi, I was wondering what kind of lightweight servers you're using.
What kind of what, sorry?
Lightweight servers you're using.
So for the stat server, it will just be something that will receive HTTPS requests and fire them off to the DLL and say, hey, what's the answer? It'll be a very, very simple, there'll be no Unity in it at all. It will just be pure C#, async await. There'll be very little. It'll be talked to a database as well, so we can store the answers. So in order to be able to produce those graphs of, how does your performance stack up with everyone else, I need to track everybody's sort of best performance on different criteria. But really it'll be, a Postgres database, a web server, and a DLL. That's it.
First of all, thanks very much. That was really, really useful, really interesting. And yeah, I really like the benefits that you talked about. I'm wondering about, for those of us that have games that might not quite fit, so maybe using dots or maybe with physics and things like that. Have you got any thoughts on how we can apply some of these principles if we're kind of constrained in other ways?
Yeah, I mean, dots is not something I've ever really fiddled with. I can't say much about that. With your physics, I mean, I suppose it again depends quite how. I mean, if you're making a racing game, I think you're probably stuffed. Yeah, I think that is the most difficult bit to get around. I think is the physics, because particularly in Unity, Unity doesn't make it easy for you to get into the guts of the physics system. If that makes sense. So you can't really, you can sort of let time progress. You can run your update loop, but you can't do much. Well, it's not as easy as it might be to do things with it. At least not last time I tried. What might I suggest? I mean, there might be bits of the system you can do this way. Anything to do with, if you're making a racing game, but the rest of your sort of season-based, what's my ranking, that needs to be in Unity. You could maybe carve out as much as possible that doesn't use the physics and go with that. But the physics stuff does make it quite hard.
Okay, no, that makes sense. Thank you.
It's more an observation than a question. Sure. I work for AntStream, which is a streaming company, and I can see how its approach would fit in very well with a streaming game. You can basically seem to separate your entire rendering engine from your game logic. So have you looked at that kind of approach, or you don't need to use Unity? I mean, I know saying that around here might be a bad thing.
Yeah, I mean, it's a puzzle game. It's not inherently all that streamable, so I've not really thought much about it.
But basically, our engine is very similar to what you're doing, only we have an emulator that runs on a server and streams input as well.
Something we wanted to do for Chronicle, I never got to, unfortunately it doesn't exist anymore as a game, was because we had all these events, we could have created replays kind of on the fly. So we could have we wanted to have a feature where we kind of pick, this is the game of the week. This had a slightly odd result, and we've got that from the analytics guys, and we can just create it in the engine. You can see it based on that. So we wanted to kind of have a replay feature for stuff we thought was interesting. And because we had all the data, we could just do that. So that's something like that. And yeah, I guess you could take those events, that data, and use it in any engine you like. You could make it work in Unreal if you wanted to. It's in C#, but other than that, I
mean, you could run the DLL on a server completely and cut out any client gameplay if you really want.
Yeah. I mean, I suppose I see what you mean. So if you've got various clients, all playing a game together that's being streamed and they're just talking to a server, you mean? To have the game server just as a, is that what you're...
You could have a common server with several players, yeah.
Yeah, I
I'm
mean,
just
yeah,
saying,
that's what...
and then you could update your game code on your server without having to update people's client.
Yeah,
Okay.
absolutely. I mean...
Probably doesn't help very much in this case, but
Yeah, I know. I mean,
with
so
this approach.
yeah, with Chronicle, it was just a C# server. The only problem, if we did an update, we had to update both sides because the practice mode had all the same code in it for the offline stuff. But yes, we could have done. I mean, RuneScape, that happens a lot all the time, actually. We can update, I'll say we, I don't work there anymore. They can update the servers without the client needing an update. Yeah, it is doable. Oh, there's one guy behind you.
Yeah, hi again. Thanks very much for your talk. It was very interesting. It's kind of a sort of a progression of your model view architecture, but it's slightly deeper. And there's lots of places, I think, in sort of your average game engine hierarchy that you can do that because you've got your actual your display refreshing at 60 frames a second. But that doesn't need to be quite as tightly coupled to your scene graph as it often is. But that's just how things are architected. And you can drive that all the way down like you've done. But obviously, one of the reasons people maybe don't do that so much is performance. It's just as you add these new layers, you get all the benefits, like being able to serialize intermediate, like you did with the time replay. But that just comes with a cost because you're no longer like working with directly with the primitives that you're handling at the higher level. So yeah, my question is really just, did you hit any issues where obviously with a puzzle game, performance is maybe not quite such an issue, but it can still, always things can blow up. Did you hit any cases where performance was an issue? Did you have any insights on how big an issue it actually is in practice and ways around it?
So yeah, thank you. I think I haven't written much more code than I'd have written if they'd been united. The code is just in different places. So what does this, what does this spray painter do in a logical sense? How does it edit the state of the factory and what animations does it play? I would need to write that anyway. Mostly I've just separated them into 2 bits. The overhead really is creating those events and kind of sending them around the loop. But they're just very small, data transfer objects. There's nothing complicated about them. They're very lightweight. So yeah, in that sense, I don't think you're not writing a lot of extra code. You've got a bit of message passing overhead. Chronicle was a much more, the performance is probably more of an issue for Chronicle with having a real-time feedback on what was going on and that kind of thing. It wasn't a problem with that. Hexahedra is a bit simpler, hasn't been a problem there. So I think, yeah, the overhead isn't as bad as it might be, given that most of the code's going to have to get written anyway, I think. So as is my wont, I rattle through that quite quickly. I tend to speed up when I'm slightly nervous. So it's a little bit early. But yeah, if anybody has any closing questions, we can tackle them. Otherwise, I think we're probably there.